Property 8. Scalar product and its distributive property over addition. What is different? In normal multiplication, 2 into 3 plus 4 equal to 2 into 3 plus 2 into 4, right? So this is the way we do the normal distributive property. Okay, here in this vector it is going to be 1. Whenever it is vector, the multiplication is nothing but either dot product or cross product. Here it is dot product. B vector plus C vector. If you do the dot product, what? A vector dot B vector plus A vector dot C vector. This is for any 3 vectors A, B, C. Right? This is what is the question. Now read the question. The scalar product is distributed. This is the property they want to prove. Okay? Let's take the proof. OA vector. Okay? Let us draw the OA vector. Okay? This is the OA vector represented by this equation. And we remember, and we just denote it by A vector. Second one we take is the OB vector, and let us draw a OB vector. Okay, and let's give it the name B vector. The third one is the BC vector. Let us draw a BC vector and denote it by C. We know OC vector is the sum representation of B vector plus C vector. That is, we know that what is OB vector and what is BC vector, right? OC is nothing but the sum of OB and BC. Okay, this represents B vector, vector addition, right? B vector plus C vector, this gives the resultant vector. So we represent it as B plus C vector. Okay, this is how the resultant vector works. Let us draw BL perpendicular to OA and CM perpendicular to OA. There are two perpendiculars. Here it is. Drawing BL perpendicular to OA is like this, right? So you can remember this is from the point B. If you draw a perpendicular, how to draw a perpendicular, the angle between them is 90 degrees. This is BL and CM. There is another perpendicular that we draw on the OA vector. Okay, here this is CM. There is another perpendicular we draw from the point C onto the vector OA. This is OA. Okay. So here we draw this CM. When it is a perpendicular, the angle is 90 degrees. BL being a perpendicular means it is a projection of this B vector onto the A vector. Okay. So what is a projection? We remember from the last problem, right? Projection is the perpendicular down from the vertex. You can say from this point LM, this point M, okay, we can call this one LM is the projection of C vector. This is the C vector, right? So on OA, we have another one that is going to be B plus C vector. Projection of B plus C vector is going to be from here till, shall we say here, yeah, this is projection of B plus C vector we are talking. So the projection of that is going to be OM. OM is projection of B vector plus C vector, and OL is going to be the projection of B vector, and LM is going to be the projection of C vector. So we need to find what? 3 things. A dot B vector, A dot C vector, A vector dot C vector, and A vector dot B vector plus C vector. Okay, there are 3 things we have to find. We will take one after the other. So first step, is A dot B vector. What is the formula? Equal to A vector modulus of A vector into modulus of B vector into cos theta. This is what? B cos theta is equal to what? OL. This is what we saw. This guy OL is nothing but B cos theta. Okay, that is equal to OL. Right? So this way we found B cos theta is OL, which is nothing but projection of this vector B vector. Okay, substituting the OL, that is the projection of that vector here. Okay, we call this, we rewrite this equation as A vector into OL. Okay, this is step 1. Then same way we have A dot C vector. A dot C vector can be written as modulus of A vector multiplied modulus of C vector. Right? So modulus of C vector cos theta. We have to look back. C cos theta is nothing but projection of C onto A. So we found the projection of C onto A is here. Is LM is the projection of vector C on OA. That is, this is A, right? So C, projection of C on A is LM. This is the thing. So A dot C, we can write it as modulus of A into LM, dot product of A with B plus C vector. So which is nothing but modulus of A into projection of B plus C on A vector, right? On OA or A vector. What is projection of A? From this picture we know the projection of B plus C on A vector is OL. OM. So we are going to substitute there. Total OM is 2 parts. One is the OL part and second is the OM part. So it has two components, OL plus LM. That is OL is nothing but projection of B vector plus projection of LM is nothing but projection of C vector. So projection of B plus C vector is nothing but sum of projection of B vector and C vector on OA. That is what is expanded here as OL plus LM, which by distributive property we can write it as multiplicative distributive property, modulus of A into OL plus modulus of A into LM. This we know is nothing but A vector and this A modulus of A vector into LM is C vector. But this formula is equal to this. This is what we found out. So we are going to substitute this here instead of this. Likewise, we found out A dot C vector as this. So we substitute this component here, C on A. Hence we can substitute this instead of this. Therefore, we have A dot B vector plus C vector here equal to A vector dot B vector and A vector dot C vector.